analogy that I often tell people is that you can imagine Google Maps without the satellite would be completely useless. So presenting a picture to the operator without connection to the hardware is completely useless. So the challenge with conventional work instructions is that simply displaying to the operator what to do and having a manual confirmation is not good enough to validate that the product is correct. That's why for many critical steps, we actually want to validate using the hardware on the station. That could be bolting tools, it could be measuring devices, it could be leak testers, that validate that the process is actually done correctly before we allow it onto the next step. And that's one of the core functions of Odin Workstation, is that we're able to connect the hardware to the image so that we can confirm that the process is correct, enabling the operator to build the right part the first time. Let me show you a little bit about some of the hardware that's connected to this station. First piece of hardware is RFID tag, which identifies a unique product. So as it comes into the station, we identify the variant that needs to be built. We display to the operator exactly the part that needs to be built. Pick to light bins are now flashing, so we can connect to lights to tell the operator what part to pick. And over here, we've got a computer vision Odin Phantom that enables, that secures the picking process. So put on my safety glove, and I can pick the product out the bin. It's detected that, and the process has now moved on to the next step. Obviously, in some cases, manual confirmation is good enough. So over here, we've got a Phantom push button that I can use to confirm that the process is okay. Another piece of hardware that's critical to validating the process is correct is obviously a barcode scanner. So over here, we've actually connected a barcode scanner. And what I can do is, if I, for example, have picked the wrong product, the system tells me that I've picked the wrong product. However, if I pick the right product, it confirms and allows me to move on to the next step. And that's one of the fundamental reasons why connecting the hardware to the work instruction is so important. And then what I want to do is I want to finish this build and actually show the bolting tool. So obviously not all operations are critical, and so manual confirmation is actually good enough. So in this case, we actually put a button up on the screen, and the operator can actually click it every time they've performed the task. One of the most critical devices on an assembly line is obviously the bolting tool. In this particular case, I've got an Atlas Copco bolting tool. It is wirelessly controlled, and it's torque and angle monitored. So we've been able to connect to this using open protocol. And what we've also done is we've integrated the computer vision system Odin Phantom to validate that the bolting tool is in the right position, and only enable the bolting tool when the bolting tool is in the right position. So as you can see here, the bolting tool is off. And when I go to the right position, not only am I indicating to the operator that the bolting tool is in the right position, I actually enable the bolting tool. And so by doing that, by integrating the hardware to the work instruction, I'm actually telling the operator very clearly what to do. And most importantly, if I go to the wrong position, that bolting tool is completely disabled. So in other words, telling the operator what not to do. So it's telling me where to go. If I go to the right position, bolting tool is enabled. So in conclusion, connecting the hardware to the work instruction is fundamental to building a good quality part and enabling the operator to build the product right first time.